Let's solve this application. Susan Grody has a 25% solution of alcohol to mix with a 40% solution to get 50 liters of a final mixture that is 30% alcohol. How much of each of the original solutions should she use? So she's got some 25%, she's going to mix with 40% to get 50 liters of a 30%. We want to read these very carefully. Now let's begin to define our variables and organize our information. We've got a couple of percent solutions that we're working with. We're working with a 25% solution. Let's write that percent in its working decimal form. We're also working with a 40% solution. Let's let X represent this unknown amount of the 25% solution. And let's let Y represent the unknown amount of the 40% solution. We know that the sum of these two solutions, as we mix them together, is going to total 50 liters. So one of our equations can come from this column right here, in that X plus Y is equal to the total of 50. Let's also determine the amount of pure alcohol that's in each of these solutions. If this first one is a 25% solution, then it is 25% alcohol. The amount of alcohol is 25% of X, indicating that we multiply 0.25 times X. The second solution is a 40% solution, indicating that it is 40% alcohol. Therefore, the amount of alcohol in it is 40% of Y, or 0.4 times Y. At the end, after we mix these two together, we're going to get a total of 50 liters of a 30% solution. It should make sense that when we add a 25% solution with a 40% solution, we get something in the middle, a 30% solution. So in the end, these amounts of pure alcohol should total the amount of pure alcohol in the mixture, which is 30% of the 50 liters. I'm going to go ahead and multiply these two values together. 0.3 times that 50 is 15. So equation 2 can come from this last column where we add the amount of alcohol in the first container plus the amount of alcohol in the second to get the amount of alcohol in the mixture. In other words, algebraically, that's 0.25x plus 0.40y is equal to, I'm just going to say, is equal to 15. Now that's the hard part. We've got our equations set up. Let's proceed to the next step where we actually solve these equations. Again, equation 1 was X plus Y is equal to 50. Just rewriting equation 2, it was 0.25x plus 0.40y is equal to 15. I'm going to go ahead and start by eliminating the decimal values from equation 2. We can multiply equation 2 through by 100 to do this. So equation 2 becomes, let's go ahead and call it a new equation 3. As we multiply 100 times each value, this becomes a 25x plus a 40y is equal to 1500. Don't forget to take the 100 times the 15 as well. Now, I don't really need to look at this equation anymore. Let's focus in on equations 1 and 3 and solve this system. Let's see, we can choose any method that we want to. I think I'll go with an elimination method. We have both of our equations in standard form. And suppose we try to eliminate the x variable. we can multiply equation 1 through by negative 25 in order to get the x's to cancel. Let's do that. Multiplying equation 1 through by negative 25. Let's see, I guess we'd call that equation number 4. That becomes a negative 25x minus 25y is equal to a negative 25 times 50, or a negative 1250. And now let's go ahead and just add equations 3 and 4 using the elimination method. The x's cancel. 40 plus a negative 25 is a 15y. 1500 plus a negative 1250 is 250. Dividing both sides by 15. 250 divided by 15. Let's go ahead and do this. That's 250 over 15. If we reduce, 5 goes into 15 3 times. 5 goes into 250 50 times. So we can write this as 50 thirds liters. Or if you want to see that in its mixed form, we can divide 3 into 50. That goes a 16 times with 2 left over. So we can also write that as 16 2/3 liters. Now let's go and solve for x as well. I think I'll take this value for y equals 16 2/3, and substitute it into equation 1. Equation 1 was x plus y equal 50. We had a y value of 16 2/3. So x is equal to that 50 minus 16 2/3, or 33 1/3 liters. Now let's go ahead and make sure we've answered the question that's asked. Well, how much of the 25% solution and how much of the 40% solution were needed? We had originally defined x as the amount of the 25% solution, and so we need 33 1/3 liters of the 25% solution. And we correspondingly then need the 16 2/3 liters of the 40% solution. Now we're almost done. Let's go ahead and as a last step, just quickly check our answers, substituting both of these values for x and y into equations 1 and 2 to ensure that they satisfy both equations. So as the last step, equation 1 was x plus y is equal to 50. Remember that we had gotten 33 1/3 for x. We had gotten 16 2/3 for y. And indeed, when we sum these together, we do get 50. The values check in equation 1. Let's check in equation 2 as well. Equation 2 was 0.25x plus 0.40 times y is equal to, and on the right-hand side of that equation we had a 15. Plugging 33 1/3 in for x, 16 2/3 in for y. We should get on the left a value of 15. This looks a little bit messy, but let's go ahead and change these decimal values into their corresponding fractional form. 0.25 is 1/4 or 1/4. 33 1/3 in its improper form. 3 times that 33 is 99, plus 1 is 100. Thirds 0.4 is a 4/10 or a 2/5 in its reduced form. 16 2/3, 3 times that 16 is a 48, plus 2 is 50 thirds. Hang in there, we're almost done. Multiplying straight across, actually I think I'll reduce first. 4 goes into itself once, into 100, 25 times. So this first product is 25 thirds. Our second product, let's reduce there as well. 5 goes into itself once, into 50, 10 times. Multiplying straight across, that is a 20 thirds. Adding the numerators then, we get a 45 thirds. Is that equal to 15? Yes, indeed. As we divide 45 by 3, we do indeed get 15. Our values for x and y worked in both equations, so we can feel confident that we do indeed have the correct solution.